look at this, boys and girls, one extra video for the fourth series. Today is going to be quite chill, to be honest, since we are going to implement the colon definition, and we can take a look at what the heck is colon definition. So we can go to the fourth this website, and if we search for this one here, we're basically going to define colon definitions, which basically allows us to define words. And this one is going to be easy because it's not going to require us to implement assembly or like do all of these different X that we did in the previous two videos. And we'll not need to like battle against whatever the fuck is going on here and do a bunch of inline assembly. We can just copy the existing assembly into a buffer and then execute that buffer. So that one is pretty cool. One thing that I want to do before doing that, I probably want to increase this to like 16 bytes or 16 megabytes. I think 16 megabytes is a better buffer size for the mmap code segment. And then, well, I guess we can start defining it, right? So we basically just need to do the following. We just need to copy this, and it's going to be similar to what we did previously. Right? We can do that. Oh, and by the way, I can also do this. Something like this: unknown words. And then add a new line or something, and put here words, so I know what the fuck is going on. But in here we can just do that, and here we need to do the stuff that we did in the other videos, mainly here. So I think this is the simplest one. Oh yeah, this one has the fuck, yeah. Yeah, but it's basically similar. So we can create a variable that is a boolean. How do they call it here? Yeah, they call it compilation mode. Yeah, compilation state. Okay. Compilation. I can call it compilation mode. False. And then I can basically do this. But here I'm going to do something slightly different from what I did here, because it's complicated the code a lot. And since we already have this next function, we can literally just do the following. So we can pop the name of the words, right? Or I can even do the following. I can literally just say word equals that, and I can overwrite because I'm not going to need this for anything. So this is the word that I'm this is the word that I'm trying to define, and so I can instantly. Oh, by the way, I'll also need a dictionary for my thing. And this can be like represented in C code. I don't think we need anything else. So yeah, I don't want to do this in assembly right now. I can just have this as a vocabulary. I know that Force calls it actually a dictionary. I got used to calling it vocabulary because of Factor. Factor is another programming language. And they call it a vocabulary in here. Okay, let me say vocabulary. Yeah. Somewhere in here it should be there. Since this is not going to be, eventually this is not going to be fourth, and I prefer the word vocabulary instead of dictionary, because dictionary can be confused with the Python dictionary, and they are not the same thing. I'm going to keep calling it a vocabulary. So I can just say that. And inside here, I'm just going to have the data, right? And this can be a pointer. I'm going to have const char words, and then I'm going to have a pointer, which can also be a constant pointer to the code segment, right? So the body. I'm going to call it code Yeah, why not? And then here I can have size t count and size t capacity. So this is another dynamic array moment. We can steal that code from here, from this sketch we did. I don't know if it's here or in the, probably it's another one, right? I remember writing the append somewhere. Append. Oh, I didn't. Oh, must be forgotten. So I wrote that macro so many times that I no longer remember exactly. So here, instead of doing that, I can do this, right? And I can just do that, so I don't need, yeah, I can do that in here. I can even zero initialize it just to make sure. And then I can have define. Oh, but here, this one, yeah, I need to extract this into a type so I can like push stuff. Or I can like do this the other way around. So I can say add vocabulary score add, and I can add a word. And well, here, oh yeah, before doing that, no, it's fine, it's fine, it's fine, yeah. But I do need to do that at the end. So I'm not going to implement this yet because before doing that, I need to implement another function, something like voice, and this is going to be like in the codes segment, so more or less here. And I can say code. How can I call this? Code append or something? I can call it code append. Yeah, I guess. And here this is just going to receive the pointer, right, to the segment. So it's going to be const char pointer, and it's going to be the beginning, and it's also going to receive the size. Why did I call it u? Oh yeah, but I can cast it to size t because I don't need. So I call this a uint pointer because here when we define this, we are actually like doing point arithmetic, but then I can cast it into a size t because it's fine. So here I just need to do mem copy, and I need to do what do I need to do? I need to append to code basically, right? And then, but here it's going to be a little bit different, but yeah, let's just keep it like this, and then size, because here I need to keep track of like how much have we actually pushed into the code segment, right? So I need to keep a track of that. I can say code, well, I can even, is this being used anywhere besides this? No. So I can do the following. I can say this is another structure. I can call it code, but here inside I can say that this is the data, and then I can have the size, right? And we know the we can even define the capacity, right? Code size or something. Yeah, I can define the size, and it's gonna be 1024 times 1024, and this is actually 16 megabytes, right? Something like this. And I cannot like put it there because I need to actually mark it as executable. So I still need to do this inside here and do that, and then here I can actually say code dot data is equal to that, right? So it's a little bit easier to work with. And then here I can actually push to code.data plus code.size. Actually, I can call it count. Right. And this is more like a capacity. I need to, yeah. start using this as a proper naming standard, because here I also called it size. I can change rename symbol. I can call it capacity. Capacity. Okay. Okay. Did I call anything else? I also call this size. Fuck. Okay. Let's rename this to capacity. Well, but this is not really a capacity because this is a fixed size of the array. This is actually correct. I should call this size. I should actually call this size because these are not dynamic arrays. So it's actually more directly correct call this a size. And this is a capacity because it's actually the capacity, and I can use the terminology capacity in count for dynamic stuff, and I can use size for static stuff, right? We can have that standard. Okay, so this basically just does this. So this basically appends some kind of instruction into there, and we can basically do the following. So if we are in compilation mode, we do something. If we are not, we just immediately evaluate the code, right? So this is what we will need to have everywhere. We immediately evaluate the code. If we are in compilation mode, we basically just need to do the following. Code appends, and here we just replace, and we will use whatever label, assembly label it was generated, right? So we can just say lit. Oh, but the literal is still going to be different because we need to actually patch the code. So let's do the easier ones first. So if we do that, so this comes here, and here we just do code append to the code segment. We are going to append dup begin. So it's the same stuff, right? We just do this, and the size is going to be dup size, right? So nothing like that strange going on. And then we just copy this everywhere, and this here we just replace this by drop. I could like abstract this code away, but I'm going to keep it like this just to be visually easy to understand what the fuck is going on. And then here we do the swap, right? So swap begin, and then swap score size. Yeah. All right, so let's assume like this is a to do, because I just want to test the idea first. And then here we need to keep track of the first position where this segment, this function is actually being appended at, right? So we also need to keep track of a const char pointer compilation score begin. So this is the beginning of the stuff. We can like null initialize, it's fine. And we can measure the size afterwards. So one very important thing to have is also here the size. Like the size of in bytes, size of machine, size in bytes actually of the generated machine code, right? So this is what this size actually is. I can remove the costs here, just it's fine. Yeah, I just remove the costs. Oh, and I need to duplicate this word actually. I need to duplicate it here because this word is going to be like overwritten because this is a temporary buffer. I cannot forget it actually. So that's that. So here we basically just keep track of that. It's fine. Oh, and by the way, did I increment? No, I forgot to increment. So I also need to do this and then do plus equal size, like so. So that's the basically entire implementation. And then here when I enter compilation mode, I need to basically first store the I could do the following. instead of doing all of this shit, I could just extract this into a type like I wanted before, and I can keep track of this inside a structure, and I don't have to play around with so many variables. Yeah. So instead of having this shit here, I can have literally a word, right? And then I can say, okay, so enter compilation mode, my word dot codes is equal to code dot data. I can even call it address. This is more like an address, right? Yeah, this is more like an address. Why are you not? Const char. What the fuck? Oh, because this is what? What the fuck is going on? Oh, I see. Fuck. Compiled words, I guess. Compiled words. Sure. We first reserve that address, and then we pick up the name. We can even do that afterwards. Like we get that. Fine, and then I can say compiled words dot word is equal to word, or I can even inline it and do it like this. All right, wait a minute, I need to sneeze. All right, it was a very long sneeze. So yeah, we get the compiled words. We can even call it like compiled words. I think it's fine. And yeah, so the last thing missing is the size of the word, right? But we can calculate that when we get to the return thingy. Yeah, we can get the return thingy, so we can just copy this, copy that, bam, bam, and then do this, and compilation mode turns into false. Then I need to basically get a compiled word dot size is going to be equal to, oh, this is a compiled word, okay, is going to be equal to, oh fuck, this is not code.data, this is code.data plus code.count, basically. Yeah. And here I can get the address, like so. And then this, I guess. And this is a minus, like this. So this is going to give me the size. I could extract this into, yeah, I don't even know if I like this. Well, I can stick to it, yeah. But I still need to append the return, right? So we still need an instruction for that. Yeah, we still need an instruction for that. I guess I can use, where is it? Because the literal is never going to use, yeah. So instead of having this here, because the literal is never going to be called immediately, so it doesn't need a return. And I can just say that, did I copy it? No, I didn't, fuck. Okay. Return, like so. And this is basically going to be return beginning, return end. So I don't want like hard code the opcodes and everything, because then if we change architecture, I need to remember that I recorded the opcode. So here I just know I just need to change this function. That's the reasoning behind it. And we need the right size, right? Yeah. And here we can first add right size, like so. Oh, I forgot. What the fuck am I doing? Okay. Right size, right end, and right begin. And so when we encounter this, we can, yeah, we can basically append, right, begin, and then right size, right? And I can even like throw an error when this is not like used in the compilation mode, and I can just say used outside, oh I cannot, outside of compilation mode. I don't know like this basically. What am I doing? Okay. Can I type today? Okay. So this should be fine. And here I can even continue because I don't want to blow up stuff. Well, apparently I cannot type today. Okay. So this is going to move to the next stuff. Cool. So here we append the return. This is going to close the compilation mode, and this is going to define the size of that word. And I mean, yeah, that's basically it. So here we just need to loop through. So we need to do this plus t I equals. Oh, I forgot. Fuck. Yeah, I forgot. I still forgot one thing. We need to still append that word to the vocabulary. Yeah. So we can just grab this. Say words. So, and we can just say the following. So if vocabulary dot count is less greater or equal than vocabulary dot capacity, can just set the capacity going to be equal capacity. If it exists, we can set it to like 64 or something if it does not exist actually. So if it does not exist, otherwise we can just double it like so, and then we can realloc stuff. So pointer and size, this is the size, that times this, right? And then the pointer is vocabulary dot data, and then that, right? Like so. And we can even assert that vocabulary data exists. There is nothing we can do if it doesn't, but at least we assert it. And then I just need to append. So it's the classical stuff. You already saw this a million times. So it is the pretty much classical stuff. We just append it like so. Alright, so when we finish the compilation of a word, we just come here, we append the return, and we do that, and you finally append the compiled word. And this word should now be inside the vocabulary. So now I can do the following. I can even add a function. I can say vocabulary finds const char pointer. Oh, I forgot. Fuck. Here I need to actually str-dup this. I cannot forget it. It's very important. Yeah, I need to str-dup this one. Okay, because this pointer is going to be invalidated, so you need to be careful with it. But yeah, that should be fine now. Here we just need to traverse, and I want to first start searching it from the end all the way up to the beginning, right? Because I want to search from the latest words until the very first word, because the latest words have priority, the latest defined words. So what can I do? I can just say I is equal to vocabulary dot count -1. But if counts, yeah, this is, if count is 0, we don't really, so I'm gonna put this as an int 64 just to be safe. because I don't want this to like underflow. And then here, while I is greater than greater or equal to 0, right? Yeah, because if this is 0, this is -1, and this is never going to run, so it's also fine. And then I do I minus minus, and then it's just the same stuff that we do here. We can just copy it here like this, and then we have word, and then we have vocabulary dot data I dot word, right? And if it's true, here we can just return the compiled words. I don't know if I want to call it compiled word, to be honest. It's a very long name. Let me just call it word. Fuck, that one needs to remain compiled word. Yeah, but the type can be just a word. And here we just return that. Well, it's also not really, it's actually a compiled word, because a word is like just a name, and the compiled word can be everything. So fuck it, let me, yeah, I cannot make like a decision about this. What am I doing? Okay, we just do that like so. Well, we could return even an integer. That's also an option. Yeah, why not? Can return an integer. So in here I can return just I, and then return -1 if that's just the case. So here we can just do index vocabulary find these words for me, please. If index is less than 0, we just do this, right? Otherwise, we do the following. We just go to vocabulary dot data dot actually index dot, and we basically just need to call this address. And to call an address, we do this, right? Like so. All right, we call the address and everything is fine. But if we are inside compilation mode, and for now, actually, if I'm also going to forbid column definitions inside column definitions. I can do inside compilation mode. So I'm going to forbid that. But if we are inside a column definition, we, instead of executing this word, we need to copy it, right? Copy it and append it, basically. So here we need to say else if compilation mode, else if else. So we found the word, compilation mode we executed, otherwise we just need to append it. Code appends, and then we just say append this address, right? And the size is just size, and everything should be fine, right? Exactly. Yeah, and only the literals are missing, but let's test it first. strdup does not exist. Why doesn't it exist? I thought it existed. What? Man, strdup. Oh, it's probably not part of the standard, because I'm using C99 standard. Fuck. And this is from why is not scrolling properly? This is from string.h, but I have string.h, right? I do have string.h, so I need to implement my own strdup. All right. So let's say word is equal to this, and then I just need to say malloc str length of word plus 1 for the termination character, right? Exactly. And yeah, it just gets the size. So should I, yeah, I should extract the size. So I can say size tn is equal to this, right? And then I can do mem cpy. This is the destination. This is the thingy, and then n is this. So I can do that, and then I can literally just inline all of this shit, and it's fine. Okay, so this is basically str-dup implemented. Cool. Is this going to work now? Apparently it does. So if I push like 42 onto the stack, do not forget that we already have argc and rv on the stack, so we are going to have argc, rv, and then 42. Then if I compile a word to say another dup, right? So this word is going to be called another dup, and it just does a dup, right? And if I call another dup, now on the stack I should have argc, argv, 42, and then 42. Fuck, we only have 142. Why didn't it? Why didn't it? That's interesting. Let me sneeze again. I need to sneeze. Sorry. All right. Yeah, I guess we need to check what the fuck is going on, right? So is this address? Yeah, this address should be fine. Or is it? No, it's fine, it's fine. So let's do the following. We print a stack, and let's also do the following. Size t I equals 0, I is less than code dot count I equals 4. Let's print everything that was inside the code stuff, right? So you can say printf x, I think it was this one. We can do space, and then we can say code dot data I, and then we can print a new line at the end, right? And then here we can also do even other stuff. We can do, oh, but this is just an address, so it's going to point, yeah, it doesn't really have that much value, to be honest. And here it does that. Let's just start debugging it like this. So if I say dup1 dup return bam bam, we get 4983. We had a bunch of stuff actually, but it seems to be correct because this is C3 is a return. But just to make sure, let's also print dup size, right? And then we can just print from dup begin, and we need to cast this into a pointer. So we need to say the following pointer, and we need to wrap even further like that. So let's just compare. They should match, right? They should be exactly the same. So if I define a dup1 with dup and then this, and then I terminate, exactly. So this is the first dup, which is fine, and this is our compiled word, which the only difference is just this C3. So it's perfectly fine. Okay, it's perfectly fine. So the bug is somewhere else. Okay, the bug is somewhere else. If this is fine, it means that we compiled it properly everywhere. Let's just add a print, I guess, here, and get whatever is in here and whatever is in here, and compare both of them. So before calling, let's print the address we had saved and we are using, and let's print code, because we know that code is going to be the address that it is going to use. Oh, actually, it's not what I want. I want code dot data. So if I do dup one, then dup, then this, bam, and then if I do dup one, it terminates. Yeah. Oh, I forgot. What is going on? Oh fuck, yeah. Well, no, it's fine. It's correct. So this is pointer 1. I'm so confused. Wait, pointer 2. This is pointer 2. I can give another new line just to be easier to understand. So this is dup 1, dup, bam. Then I do dup 1, bam. I terminate. Why is it? Yeah, it's not printing. What? So it's not entering. What is going on? So printf hello or something. It's something very weird because it feels like it's not entering. Is it entering here when it shouldn't? I don't know. That's right. But if it's entering, it should at least print that, shouldn't it? Oh, fuck! I found the bug. I found the bug. Wait, guys, I found the bug. This should be. It swapped. Fucking hell! I make so many of these mistakes. Right, my brain is melting with age. I didn't used to make these kinds of mistakes when I was younger, but now I swapped shit all the time. Maybe because I'm dyslexic or something. Alright, so dup, and then I do dup 1. Well, at least we got the segmentation fault. Okay, at least it's something. At least it's something. So now let's bring back the other print because it may be the wrong address. We need to check that, right? So we need to say pointer 1 is this stuff, and then we have pointer 2, which is that stuff. And the pointer 1 can be codes, and the pointer 2 can be this scheisse. Code data. I always forget. Alright, so let's one more try. Let's call it just D, bam bam. I do D, segmentation fault. So it printed, but it, oh yeah, I forgot a new line, it didn't flush. One more try. Bam, D. Alright, so the address is the same. To be honest, the address is the same. Interesting. Why are you, what the fuck is going on? So you don't like this call. So instead of doing this, should I call you as a function? But if I call you as a function, then you're going to fuck up. No, you're not going to fuck up the arrays. Actually, it's fine, I think. I think so. So if I do the following, let's try one two. I was not expecting to have to do this kind of compiler mingling shitty but stuff, but anyways. Voice, then pointer f, I can call it func, I don't know. And voice, or actually this one. I say f, voice, bam. So if I cast this into f, right? And then I call it as a function, are you still going to, parentheses need to be here, I believe. Yeah. Are you still going to like throw that error? So if I do then d do bam bam and then I call d, no. So that was the issue. Interesting. That's very interesting. So I need two different, look at this shit, man. I need two different ways of calling JIT compiled code. Not like this one is actually not JIT compiled, to be honest. This one is compiled by the GNU assembler, and then I just reference it by label. And this one is actually compiled by me at runtime and then into machine code, and I just run the machine code. But they are still codes, right? And I still need two different ways of calling this. I don't know why. I'm gonna be honest, I don't know why. Let me try one thing. So if I do, instead of doing call, if I do this, is this going to work? That's a very like important question I need to answer. Oh yeah, I can do that like this. So if I do that and I just do loop, bam, it worked. So I do not need, I can clean some shit. I do not need this call. I can remove it and I can simplify this stuff. I just need this. I don't know if this is prettier, to be honest. But I guess so. I can make a like what can I do? I can where was it? Where I've already lost the code. Where is my type? It's here. Like let's say C anonymous, because I know how to do this kind of shit with a name, but I don't know without a name. Equals function pointer type from void to void. How can I do that? Is that the same, or is it? Man, so much. Okay. Yeah, but I don't want to give it a name because void pointer void. Okay, it's probably this one that I want. Pointer to a function taking a yeah, this is a pointer to a function taking void and returning void. But so this one cannot be a pointer. Yeah, that one cannot be a pointer. So I don't want exactly this. I want this. And here I can define call, right? This is address, and then I can have the address here. So I cast the address into this sheet, and then I just call it like that. And I no longer need assembly. And this is slightly simpler and it's easier to understand. Expected. What did you expect? Oh, it needs like stuff around this, I guess. Yep. Okay, so if I do call that, and then I do call this, now I can share this macro, and it should work for both, I suppose. Let's just confirm you guys. What the fuck is going on? Yeah, this one needs to be address, and I can cast it into a void pointer. Do I need to cast it into a void pointer? Let me try not to do that first, and then if I only do it if I actually need it. Okay, I don't need to cast it to a void pointer, but I need to take the address of that shit. Well, this is already a fucking address. Oh my god. So I need oh, maybe that's why it failed, actually. That's why the assembly code failed. Because this is already an address, right? So let me not use an address here. And then I just presume like this. But this is not going to throw an error. Or it's actually going to throw an error at compile time. But yeah, so if we do this, like so, and I just use call there, okay. So if I do just a normal dupe, it works. If I do a define another word that calls a dupe inside it, I forgot to call it, sorry. So I need to do this dupe, that, then that, and then that. Yeah, it worked. So that's the stack. I can say, so this is the, I can call it codes. Yeah, I think it's reasonable. And here I can say stack, right? Where is the macro? It's here. I just say stack. All right, so let's just go through all of the commands just to make sure everything is fine. So this is like the clean state. We have a stack with argc argv and no calls in the code segment. Then if we do dupe, for example, we have a dupe. Okay. If we do the dupe that and then call d and then do that, we have still the same dupe, but we now have code compiled into the code segment. All right, and this was the one that was executed. Then if we do like drop, for example, we get that, fine. If we do the drop bam bam and then we call d and then do that, as you can see here, the code segment is different, right? Like the return is the same, but everything else is different, or more or less different. Then we can also test the swap. So this is a usual swap. Okay, the values were swapped. This is the swap inside another word, and if I call it just s, bam bam, it's the same. And swap is actually quite a big word. It takes quite a few bytes. All right, but now let's try something more complicated. First, let's define, let's say, dupe2 or something, or let's say define word 1, which contains a dupe followed by a drop. So this should not do anything at all, because this is going to duplicate the top of stack and then immediately drop it. Okay, it worked, it compiled. Then if we define word 2 that contains word 1, right? Actually, first let me check. Okay, so this is the word definition. Now let's try to do the same, like so. And then if we do word 2, and word 2 contains word 1 and a swap, for example, and we do this, okay, and then we call word 2, the two values of the stack should be swapped and everything else should remain the same. Okay, and then here, let's try to, fuck, this copied, oh yeah, fuck, because this copied the return. That's why it's fucked actually. This copied the return. So there's a bug. There is one slight bug. Wait a minute. There's one slight bug because here we cannot fucking copy the return. So here we need to subtract return size because we don't want to copy the return because the return is going to be copied. Yeah, so that was actually interesting scenario. So let's try again. So I can redefine my word 1. Okay, I can redefine my word 2 like so, and then I can call the word 2. Okay, and if I turn, okay, so let's compare it like this. So this was the, fuck, let me, okay, okay, it's fine. So ignore this middle one, ignore this one. We got the value swapped if it is expected behavior. Then we got, no, it still copied C3. Why did you still copy C3? What the fuck? Well, but there is some value missing somewhere, right? Oh, it's here, yeah. Because this one is the same. And then this C3 didn't got copied. So let me think about this. Let me think. So why is this C3 still inside? Oh, I see. Yeah, but it well, does it make sense? So let's do a simpler scenario. I have word 1 with dupe inside. I have word 2 with word 1 followed by a drop. Or actually, let me just do this. Okay. So this is just word 1 defined. Cool. Then I define word 1, which is exactly the same. Then word 2, which contains word 1 plus a drop afterwards. What do we get? Yeah, it's still copying. But does it? So this one is calling. But I'm inlining everything. That's the weird stuff, right? So I get that. It's still doing that. And then it does the drop. The drop is actually quite large, isn't it? Am I... Oh, fuck, I'm so stupid. Oh my god. Okay. It's actually correct. It's actually correct. Look, this is word 1, okay? And this is word 2. So this is why it's copied, yeah, because I'm inlining everything. I'm inlining it. You see? Everything is in line. Everything is in line. Yeah. Yeah, exactly. Exactly. Everything is in line. Yeah, I think like we can like it's very easy to not inline everything. We can literally just do the following. Here actually I forgot this is not true. We don't need this. What can we do? To not inline it, we can actually do something very simple. Well, no, we need to do a call. So we need to bring back the call codes. Oh, but the call code will still need patching, like the literal will need patching. So let's first handle the literal, and then we handle the calling codes. Yeah. So here we'll need to do something slightly different because we'll need code append and patch, right? So we can say code append and patch, and we need this begin size, and then const char patch begin, right, the beginning of the patch, and size t patch size, and we can also have patch values. So let's say something like this with 64 like this and patch value, right? So this is a very long function, but it's fine. So here we can first do code appends, and we append begin and size, and then we need to do a mem copy from patch begin, and this is no longer needed, patch size. Oh yeah, do I want to support more than 64 bits patches? Probably not. So let's keep this simple and just do that, right? Actually, this is a pointer, right? So this is code append and patch, and then here in the literal we just do this, and so if we are in compilation mode, we just do lit begin, then lit size, and then the patch value is going to be this one still needs to be extracted here because we need a value everywhere, right? Then the value is going to be this one. Then patch begin. So the beginning of the patch is going to be lit end minus size of int64, right? Or i64. And then the patch size is the same. So I'm going to copy this amount of bytes there. All right. Okay, I think that's good. Yeah, and this should now work for, oh fuck. Oh yeah, I don't know what. Mem copy these cards. What? Oh yeah, this is oh yeah, it's yeah. But why did, oh, it didn't complain because I'm adding stuff here. Man, C is such an untyped language, I swear to God. I don't know who decided to call C a statically typed language, because I can literally just add some random number into a pointer and now the const is already like fine. I know this is like const character and not const pointer. Well, I could still do this shit and it still compile. I can write. Well, no, it's actually. Oh, it complains about duplicate. Okay, but if I do this, so char const pointer, it's still not going to complain. Yeah. So, I mean, like it's a language pretending to be static, I guess. All right, but if I do like 42, okay, it worked. If I do now, I define a word, and I can say num, and I push 42. All right, so something fucked. Something's fucked. Segmentation fault. So I suppose. Oh yeah, because patch begin. Yeah, this is completely wrong. This is actually completely wrong. So one thing. This can be like patch offset first. Size t. If this can be patch offset. We can store the position. Void pointer result. We can store where this was the destination basically. This I can call it DST. Like this. And then I can return DST, and this is going to be void pointer, like so. And then here I can get the DST, right? This destination, and then here I need to do DST plus patch offset, and I need to move copy stuff into that. So here my offset is going to be it's actually going to be this. No, is it? My offset is going to be so okay, this is going to be a large one, so let me extract this into variable. My offset is going to be first the size, yeah, first lit, and so basically lit. Oh no, it's quite simple because I already have lit size, right? So it's basically lit size minus this. So it's not that hard actually. I can literally just do this. And it's probably fine. Let's try it. With that, okay, it didn't complain. If I do n a bunch of times, right, and I execute this function a bunch of times and then I terminate, I'm gonna have a bunch of 42s. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. This, yeah, and this code was executed repeatedly. And as you can see here, this is the number 42 in here. So it is in fact cool. Let's not do every single thing as inlined. So what do I want? I want the, yeah, so this is a call stuff. Where does it go? So this is the opcode, and I want call, near call. Oh, and by the way, this one is no longer used. This one I researched it offline. What the fuck is a for call? This one was used like in 32-bit modes and 16-bit modes, where it actually needed to pop two different things to do the call. I think they explain it here. So yeah, I can leave like a link in the description if you want, and you can read it. But this was like very old stuff, so we can use near call every time. That's not a concern. And the one we need is basically this one, right? So I presume this is going to be similar because it's going to be FF as opcode. So it's going to be similar to the literal, right? FF as a opcode, and then it's going to have the address basically, M64. So if I do the following, so here let's add call as well, I guess. Call, and it's going to be call And here we can put like 0. It's fine, something like this. So we're going to call a null address, but we are going to patch it, so do not worry. Here, call begin, call end. I should start like formatting this more or less like in a different way, but I don't know. I can do this, I guess. Yeah, I guess. And this kind of looks like a table. So this is like a table of all possible instructions you can have. Yeah, I guess. And then here, no, I can keep this as in a single line. And it's going to be call size. Right, so we do the same boilerplate code that we did in everything else. Like so, bam, 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 call, and then bam. Right, so if I can define like a threshold, the inline threshold. So we are already having optimization, guys. Look at this. We are already capable of inlining codes or just calling the function. You can see this is quite a very smart compiler. So we can have like inline thresholds. How many bytes do I want? To test this, let's start with 0. Let's start with this 0. So here I can say if I need this stuff, right? If this stuff is greater than inline threshold, then I do something else. I can do the exact same thing. So this is going to be inlining, and the code above here is going to do something else. And to do this, instead of doing that, I can actually do this code append and patch. So I need to append call begin, call size. My value is going to be this, the address, right? Then this is just going to be call size minus, fuck, I can extract this actually. Int 864, yeah, I can do, so this is my address, so I can extract that stuff here and make this a little bit tidier. So here, address, and this should be everything we need. So we are just appending a single instruction, assembly instruction, like a single machine code instruction, which is a call to a very specific address. And now, okay. Yeah, I want to do that if I'm allowed to. Let's just cast it. Operand size mismatch for call. Is it because I forgot? No, I did it. Huh. Fuck, I can never remember this kind of shit. So M. I guess this is like a stuff for the clanker. Yeah, we haven't used the clanker today, so let's just use it. Oh, I see. You want the star. It's missing the star, guys. Look at this. No, I still immediate operand illegal with absolute jump. Yep. Use some random mock value. I am going to patch it afterwards anyways. but I am going to patch it with an immediate value. Right, this is actually important. Well, that's one way of doing it. That's actually one way of doing it. Yeah, why not? Yeah, I can even do that. Actually, that's not actually that bad. So I can even do like some random one. I can even call like the same address. I can even call this, and I don't need anything extra here. So this is going like this is going to be Stack Overflowing if it enters into a loop if I don't patch it correctly. So if I define n 42 bam bam, let's see what the memory contains first. So this is lit. Oh yeah, fuck, this is not the case. We first need to define n42 that like that. This is going to inline it because 42 is like a primitive, and primitives are always going to be inlined, right? Yeah. And then if I define a word that calls n, this one should actually be inline. So our code ends. Wait. Why didn't you? What? So n is going to leak now. Is going to leak. Yeah, I think so. Let me define with a simpler word. So the dupe, I think dupe is quite small, isn't it? Yeah, dupe is small. So if I do dupe bam bam, and I do d1, which is just called d bam. Yeah, so 49, then 10, 10, 10. Then there is something fucked. Okay, so I'm not copying it into the correct place. I think so. All right. Yeah, this is not called. What the fuck am I doing? Oh no, this is begin size. Call begin, call size. Fetch value, which is the address. Then patch offset, which is correct. Yes. Then patch size. Yeah. But if I do this with something like, wait a minute, here, no, it should work. Yeah. Did I forget? No, I didn't forget to. If I do this, and then W, and I happen to call N, yeah, it's going to do segmentation fault because it's completely fucked. Why are you? Okay, so if I do N and then 42, and then I do N1 and then like 24, and I print the memory. But this is D2, yeah, fuck. Oh, I have the example here. So this one, yeah, it prints 49, 83, C4, and then C3 in this column. 89, 40, what? 49, 83. Yeah, 49, 83, C4, C3. Yeah, that's correct. That's correct. So there is something about this code that is fucked. Call append and patch. Call append and patch. But the call append and patch, yeah, maybe I do not know the exact thingy. So this one is FF, I suppose. I suppose the opcode is FF. Let's do the following. That's then call size I++, and then I do that, bam, then I do call begin, and this needs to be casted into a pointer like this, and then it needs to be dereferenced again, like so. And I do that. So what exactly? Oh, this is an E8. Oh, it's using this one. Fuck. So the clanker actually suggested this set data section. Let's try to add this because it needs to use the actual correct opcode. This is not using the correct opcode. So we actually may need to do the data section trick. We may actually need to do this. Okay, so let's say this is data section. We define it, and this is text section where you can just use the jump target. 1, 2, 3, 4, 5, 6, 7, 8. Okay, it should be fine. So if we do this now, it still uses E8. E8. Is it because the number is not big enough? So 9, like if I do 2 to the power of 32, I get this number. Do that, and then I increment it, I don't know, 2 zeros. Are you still going to use that opcode? Why are you? Okay, maybe this one. Okay. E8 still. But it is truncating the value. What? Value 4 to 9 for... But why? Do I need to like do I need to save it into a register and then call it from the register? Why is this not working? Find bug. We are back at the clanker doing clanker things. And then I can actually provide this because this is actually a very interesting error. So how can I trigger the assembler to assemble with these opcodes? I would like to know. I feel like I need to learn more about. Oh, it's not a dot long, it's a quad. Yeah, fucking hell. In assembly, a long is not 64 bits, it's 32. A quad is actually, but it's still using E8. It's still using E8. Maybe, yeah, maybe because I need that stuff. Cannot be used when making a pi object. We compile with relocation. So if I do this, are you going to work? Call begin. Call not cannot be used when making a pi object. Why do I need an fpi flag? Why do I need it? Yeah, but I don't. The issue here is that you are trying to create a position independent executable, but your code is not position independent. When you use mmap to allocate memory for your code and then try to execute it, the linker doesn't know where the code will be loaded at runtime. So it can't resolve the traces of the labels. Is there any solution that does not require a special flag? Because I want like people that go to my repository when I publish it to be able to just compile it without any special flags. Yeah, but it's doing that shit. Yeah. Less portal. I don't care. So here it is suggesting doing a move. Okay, that's one way. That's one way. So I need to move something into the register. Yeah. I need to move something into a register and then call from that register. Do I want to do that? I can try it. I can try it. So this sheet is no longer needed, right? We can, I mean, we can try it. It doesn't hurt. So we first need to move stuff like this into, we can move it into our temporary register, which is R14. So we can do R14. And then we can call whatever is inside R14. And then here, this is output actually. What to, yeah, I want that. And then R14. Right, and this also changes memory, I suppose, because it's going to, the call instruction going to push stuff and whatever. So does this compile at least? Junk call. Why are you calling my call junk? Right, why are you calling my call junk? What? No, that's not true. So what I still need to understand, to requires a memory operand or the register operand that contains the address to the call. This symbol is used to dereference the register operand, the address stored in R14. I guess that's what I want, right? But still, why is it calling junk call after register? What the fuck are you even talking about? If I do this, I do that. Let's say I remove all of this shit. Operand number out of range. So if I do that, I'm still complaining. Is it because, but this one worked, right? Because it worked here, so it didn't complain about that. Jungle, what the fuck are you talking about? Let's try again. New chats, bam bam. And I can actually search in Stack Overflow or something. Man, I was not really in the mood to have these kinds of issues this video, but apparently these issues chase me. Yeah, but that's what I already did. That's what I already did, man. I can try again, but yeah. So x8664 call immediate address. Address of the function. Sure, but this is just summarizing This is just summarizing the page that I just read. Like, I swear, I don't know why people allow this kind of stuff. That these LLMs can just web scrap and pretend they are doing information when they are not. But anyways, yeah. But this is using a label, right? And we already saw, like, maybe if I do this, but this, we already had this issue, right? Because this was going to use the incorrect operands, right? This was going to use incorrect operands. How do I make as use the FF operands? 64-bit. Well, currently I have, or maybe this is just no, it shouldn't be printing the other way around, right? It shouldn't actually be doing it. I mean, that's what I was trying to do. Or I can do that, maybe. Maybe that's going to work. So, I don't know, I can have like a function. Can I call the same function? If I do this, are you going to use... No, you're still going to use that shit. So let's try this one once again. Right? And then this one. This one used 49BE. What the fuck is even that? 49BE. Oh, oh yeah. Yeah, because that's move. Fuck. So, let's try to do just a bunch of F's. So 1, 2, 3, 4, 5, 6, 7, 8. This one should be a full word, a 64-bit word full of F's. Yeah. And now you are telling me that you are using 41. Bruh, 41 is not even here. I mean, but at least compiles, right? At least it does compile. And we can work with it, I guess. So 49BE, okay, but that's fine. Where 41 is a prefix byte, where the fuck does that... There is no 41 here. Am I stupid? So there is only one call. How can that possibly be 41? What? So call syscall, VM call. What the fuck? Let me do this. Okay, how can 41? It's when these are the docs. Or are these the docs for... Oh fuck, too much docs. Too much docs, okay. Or maybe these are docs just for... No, but they are 64 bits as well. They are not just 32 bits. How many, like, how much... Why? Are you happy now? Okay. Oh, I see. The Rex stuff, like the Rex is 64 bits. Yeah. Register specifier Okay. But what if I do something like this? So can I just inline this and see what happens? No, this doesn't allow me to do this kind of shit. This does not allow me to do it. How do I use a single call with an address? Yeah, but this doesn't work, buddy. What is it? Inline assembly you can use? Dot plus 0. I didn't see this anywhere. Oh, okay. Yeah, I guess so. Is this going to work? Oh yeah. But it's E8 again. I don't want it to be E8. What about if I use that it is suggesting? F, and then I have 1, 2, 3, 4, 5. But that's only 5. Why it's only 5? What if I use, like, I don't know, Lux? Okay. But why did it... I can also try 0. What? Tells assembler to generate the RIP relative address, which is a 64-bit address calculated at runtime. But, buddy, this does not generate the opcode that we want. This generates these opcodes. This instruction. Yeah, FF I can see, but this is not 64-bit fucking. Call L1. I can try that. Let's try this. I mean, this is basically doing this, right? Call dot. Well, let's have the L1 that they dot L1 that they are suggesting. Maybe the dot that makes a difference. I don't know. E8. E8 is not what we want, because E8 is still 32-bit mode. Is still 32-bit mode, right? This generates. So I think we will need to go back to the move to register. But I need a 64-bit address. We need to go back to the register for now, and then we can, like, try to optimize this later. Yeah, I guess we need this. I guess we need this. What's the difference? What's the difference? Like, it keeps suggesting me this kind of shit, but so that's FF. Then this is like the modifier, and this is still 32 bits. Still not what I want. Still not what I want. So I think I will be forced to have this shit, right? This shit. Oh, it's already here. It's already commented. Okay. So I can remove that, and then I can do bam, 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 and here I can just say zeros. like so. Okay, and that's it's 49BE. I assume 49BE decode this. 49BE is probably like this is opcode and then that modifier. This is modifier, I presume. This is like the Rex modes. Okay, fine. Oh wait, BE is of opcode. Okay, load 64-bit immediate file into register. Okay, so um, so we will need to do the following. I want this have that like this scenario cannot have hard-coded values. So we can have a helper. Oh, but this is so fucked, man. To be honest, this is so fucked. Let me think about it. I was trying to extract this into a separate assembly and then I can compute it otherwise. But let's hard code it for now. Let's hard code the 2 bytes for now. So basically, what we'll need to do, call begin, it's fine. Call size, it's fine. Then address is the value, yes. The offset is going to be 2, and here find a way to factor this constant, because it's this is not platform independent, right? But and this is the what we want. Okay, so let me remove this because this is no longer needed. Okay, so let's try again. We do words 1, which does 42, and bam, and let's say okay, that's what we have. If we define word 1 again, which is 42, then word 2, which calls word 1, and we do that. Okay, so this is word 1, cool, and then this is word 2. 49BE is the move. Then we should have 1, 2, 3, 4, 5, 6, 7, 8 bytes. That's fine. And then we have a call and then a return. It should be working. It should be working. So if I define, I don't know, D as loop, then I define the 42, which just does the, well, I can actually even define N, which pushes 42. And then I define, let's say, D42, for example, which does the loop followed by 42. And then I call D42. So what should happen here? The first element of, so this one should be duplicated. So you had 2, then did that, and then we should get a 42 after that. It's working. Okay, it's working. Thank God. All right, so and this is basically, so blah blah blah, where is it? Yeah, so this is the same, or it should be the same code, isn't it? No, apparently it's not. Oh yeah, because here I use a dupe. Fuck. So where is the first function? Is this the first function? No, okay, this is the dupe. Okay, this is the dupe. Then this is n, which pushes 42, and then this is my d42, but this is 49 by, okay, yeah, 49BE, and then 1, 2, 3, 4, 5, 2, 3, 4, 5, 6, 7, 8. Then we have that 41FF, and then we have, where is our other 49BE? Which should have another call. Let's try to, okay, because this. Let's try to see, because I should have another but I don't, where is it? I don't see it. I don't see any other 49BE, to be honest. This one. Okay, so this is the move stuff. Then we have the call. Why do we have ads? Oh fuck! I did, yeah, it's correct. Actually, the code was correct. I actually made a mistake. So this is this is n42, and then I need to define a d42 as d followed by n actually, right? And if I do d42 and terminate, okay. So then we can compare. Yeah, actually this is shorter code. Interesting. So C3, this is dup, right? This is our d words. Then this is our n words. These two, yeah. This everything, all of this is the n words. Then 49be is a call all the way up to, where was it? 49, and then this is another call, right? So we have two calls, one and then another. So basically, each call takes will always take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, plus the return on the other side, 14 instructions, right? 14 bytes actually. So that's 13 for the move plus call, and then ret is another one. So in total we have 14. Now what should be our threshold? So anything, it's almost like certain, anything below 14 should be inlined, right? Anything below 14 bytes should be inlined. But I don't think this is an actual a sensible value or a reasonable one. We should even be more aggressive. And I think we should be even more aggressive than 16, because let's imagine this. Return and call, they still need to push and pop stuff from memory, right? Sure, that stuff is going to be cached in L1 cache or whatever the architecture of the CPU allows. So we still need to take that into account. I think that 32 is a reasonable value. I think that actually 32 is pretty reasonable value. And so with this, let's say, so for each number, my word as is 8. So 8 plus 8, 16. So a word with four literals inside of it. Oh, actually, the lit is actually bigger than that, isn't it? Yeah. So 32 is actually quite a small value, I would say, because dup is a small word, drop is a small word, swap is slightly bigger, lit is the biggest one, because this one requires just this part component requires 8 bytes, right? So let's try something. If I have a word, let's call it n, the n word, and we had 40 to 69 for 20. This one should already take quite a few bytes. Yeah, this one should take a massive amount of bytes. So how many of them are there? So let's try to count of these like this. Yeah, lots of them, 55. So this very small word already takes 55 bytes. And well, maybe we can do 64. Like we can tune this later, of course, and we can have proper like testing and benchmarks once we have like a better system. So let's just say 64. So right, and now let's have macros, so we can have feature parity with what we did on the first episode, like on the first video, where we were able to implement a full fourth system, including macros and recursion and all of that good stuff. So let's I don't think we will have recursion, because we still need to tune a few things, because we only add the word to the vocabulary once that word has been fully compiled, right? And fourth, by the way, it also does not have recursion by name. It has a special word to the recursion. But yeah, so here the only thing we need to do the only thing we need to do is this stuff. Yeah, I can copy it for now. Yeah, it's fine. So it's this stuff, right? And here we just need to push the address of the thing, right? And the address of this thing needs to go into a function. So I can say void colon like so, and now I can take this out of here, I believe. Does this change? Yes, it does. Okay. So I can do that, right? And I need to move all of these. And since this doesn't have any kind of assembly in it, it's fine to copy and paste it into a function. If it had assembly, we would need to keep it inside the same scope, right? Here I can provide itself, so I can call this function by itself. And here I can say in 64 because I know this is always be 64, right? And then for words, fuck. Well, it's not actually fuck. You can do const char that and it's fixed. Cool. So while we are doing it, because does this need to be okay? I forgot. I should do this actually. Okay. Does this need to be here? Because yeah, so when this executes as a compiled thing, will compile. Yeah, we can have actual. Fuck, this is actually quite interesting. Interesting. Okay. So we just need to call this here, and it's going to work, I assume. And I can show you why this is very interesting. Let me just also extract the semicolon. So this is the semicolon, and here we just need to do something very similar, right? Here we don't care about that. This is a call here we provide semicolon, here is the same, and here we just do this shit exactly, right? And then we can get semicolon and call it here. Okay, it's getting somewhere. And now let's just test the behavior. Okay, fuck. The behavior remains the same. Should I do this instead? I'm not really sure. So it requires me to cast it into, well, oh, but that's, yeah, so this is a pointer. Let me cast it into an int. I think casting it into an int is going to work, but I'm not really sure. Okay, so if I execute like a normal column definition, it works. If I call n, fuck, it failed. Why did it fail? So is compilation mode, Word is going to work. What's the difference? I'm gonna be honest, what's the difference? So if I do n42, bam, bam, bam. So I have 49. Wait a minute. Where is my C3? What? Yeah. Semicolon is fucked, I think. Why didn't you append? Okay, okay. So begin right size, but you still didn't do it, huh? So if I do that, let's just assume, like, I'm gonna remove it later, but just copy this just to make sure that I'm not hallucinating. Okay, if I do that and 42 bam bam, and it still gets what? Why is it getting a segmentation fault? Oh, I see. Wait, do I see it? I think well, here if it is not, well, wait, what am I doing? So if it is inside compilation mode, I need to treat it as a call, yes. Here if it is inside compilation mode, if it is, oh yeah, yeah, fuck, this needs to be the other stuff. It needs to become an integer, right? Because I need to keep track of like the stack, right? This needs to look like a counter, so yeah. This is the same problem we had on the first video. So if compilation mode, if this is a compilation mode, it's not true, so yeah, if it's 0, it's not going to get in, that's fine. And no matter what value this is in here, this is correct. We just need to increment this here, right? Then here we should only do this call. I need to think about, so if we have like something like this, like colon ret, so this one is 0, it's 0 does not go here, it increments, it's 1 now, then it goes back, is 2, then here this should decrement it, but here if compilation mode, so it's correct, it goes, no, the decrementation should happen, wait, that's interesting. So I entered that, wait, I think it should happen both, right? So this is 0, it gets there, it's 1, then it doesn't get incremented, so this should always be incremented, right? So this is 0, it gets here, this is 1, oh okay, I see, this should increment it at the end. So this is 0, it doesn't get there, it gets there, it's compiled as a normal definition at immediately, right? This is now 1, it gets there, and then there, it's 2. It's 2, I should do this, so it's fine, and I should always decrement it, right? So it gets here, it's 1, it's 1, still fine, passes, and then it gets incremented again, it's 0, 0 does not go, it's here, it's fine. I think this is a fix. So if I do this and 32 bam bam, C3 is all okay. So I think I fixed it. Let's just do another test. Okay, and it's working. Okay, so that was a fix. So now I should always also support macros. So if I do macro, and I should have actually multi-level macros, I can have words defining words defining words defining words, right? So if I do macro 1, let's do something simple, and this macro defines a word that let's say this macro defines n that pushes 42. Okay, it fucked. This fucked. But where is exactly? Is it fucked? So can I define something simpler? So I can define this, right? Yes. Can I define n that defines a1? I cannot. So the issue is somewhere, let's say, it's either here, colon, right? Begin. It's either here or in the other one. I assume it's not in the others. So this is semi. Man, I cannot type today, I swear. This is semi and so let's just try to understand what is going on. If I define that, which defines that, which defines, let's say M1, bam, bam. So colon begin, it entered here. It consumed that. It consumed this. It consumed that. Then this entered. So you're telling me, huh? But this one didn't even get printed, which is very strange. Did you fuck up here? Is that what happened? Let's even go further and do it actually here. So I can just say this word, bam, then, and then ends. Okay. If I do n, which defines m, which pushes one, and I close both. Huh, so it failed. It actually failed. What? Oh, I see. Fuck. Yeah, we are not going to have macros. Of course we are not going to have macros. I forgot. Unless, well, yeah, this is not going to work yet. It's not going to work yet. Because that would need to push atoms to somewhere. Yeah. And then I would need to redirect. Fuck. Yeah. This is not. So forget everything I said. Forget everything. Let's revert it. Let's revert all of these because this is hard to support actually. So we are not going to have macros in this video. Yeah. Forgot everything. Well, I could keep this inside functions, but let's just keep in the main scope for now. Yeah, that's a lot of changes I did actually. So yeah, so none of these is actually useful. Yeah, it's harder than I thought. So you still need shit from me, don't you? Yeah, so that's, yeah, I can do 64 and it should be fine. Okay, so it was actually interesting because basically to support compiled columns and columns running at compile time, we would also need to be able to redirect this buffer to something basically, and we would need to persist these words into a buffer, and we would actually need to have two modes, one compilation mode and then one persistence mode or something like that, that will just write the string into some place, and then the compiled column would need to swap temporarily the reading, and it would basically need to execute all of this shit. Yeah. So it's not that easy. Actually, it's not that easy. So for now, let's keep it like this. So if I try to do a macro, it's basically going to tell me used inside compilation mode is going to cheat itself, but it's fine. So is there any, like, I don't even have arithmetic operations, but I guess the episode is already too long, so I think it's everything for today. We actually did implement quite a few things if you think about it, and like we implemented the most important feature in fourth, which is the column definition. Let's say, like, I don't know, how can I exemplify how interesting this is? So I can do a swap 69 420 loop, and then I don't know 5 drop So if I do that, so this function should swap those values. So I should get the pointer and then 2, then 69, 420, 420, and this value is going to be dropped. I forgot to execute it. Yeah. Fuck, I forgot to execute again. Man, I'm already getting tired. Yeah. What hour is it? Okay, 10:30. Oh wait, now. Oh, I redefined swapped. Okay. What's going to happen here? Okay. Yeah, it's not going to execute it. So if I do this, can I? Oh, I cannot. Okay. Okay, I need to. Let's say swap 69 for 20. Loop. Sorry, drop. And execute this. Yeah, it's actually, yeah, it did work. But as you can see, like the code actually gets quite large. So this simple function, I mean, and this is not because the code is not optimized, right? This is as small as can possibly be. Like any bytecode would be larger. Like anything above this, because this is already machine code, would need more bytes. So, I mean, that's what we're dealing with. And since it is 64-bit mode, there isn't much we can do, I think. So basically, this little function consumed 83 bytes. I mean, it's not that much considering that we were using 1, 2, 3 numbers, and each number consumes 8 bytes. So that's at least just in numbers 24 bytes, and then everything else was instructions. So it's where like 60 bytes for instructions, and then 20 bytes, let's say, rounded for numbers. So I mean, it's not that bad. It's not that bad. Like, as I said, like bytecode would be much larger than this. So yeah, I guess that's everything for today. We actually achieved quite a lot of things, and we can start moving into more functional stuff, and actually proper stuff. But yeah, I mean, it's not that large, the code base. So we get this. Like this is for like the REPL. Then we have the table of current primitives we support and the primitives themselves. We have the stack, right? We have the codes. We have like the literal macro and the print stack macro, a few helper functions, and then we have the vocabulary, and that's it, right? Everything else just initialization and the running loop. So this loop is already pretty powerful, I would say. I'm happy with the result. So yeah, I see you in the next one. Bye.